All right, we've got another kind of reaction stoichiometry problem that we're going to do. This one gets us from mass to volume of a liquid, and we're going to use another conversion factor. This one is going to be the conversion factor of density. So let's dive right on into a problem. This one says, how many liters of bromine are needed to react? Okay, so I know that bromine is a reactant, so Br2, bromine's a liquid. How many liters of liquid bromine are needed to react completely with 400 grams of calcium iodide? Okay, so calcium iodide is CaI2. And then, of course, this is going to be a single replacement reaction, giving me calcium bromide plus iodine. Yeah, plus iodine. Okay, need to balance it, and it actually is already balanced, so that's nice. And I'm starting off with 400 grams of calcium iodide. Okay, so now we need to figure out what we need to do. We need to do our mole road. Okay, so I've got 400 grams already. Can I go from grams to moles? Yes. Okay, can I go from moles of this to moles of bromine, which is what I'm looking for? Yes. Okay, now though, oh, I forgot to find out what I'm looking for. I'm looking for question mark liters. Okay, so now what most of y'all are saying is, oh, Mr. Coder, you can go from moles to liters using 22.4. Okay, go back and take a look at your notes though, and you're going to see that you can only use 22.4 for liters of a gas. Okay, now as we see, this right here is actually a liquid, so we can not use 22.4. However, I do have one more very important piece of information. I have the density. Okay, now this says that the density is 3.12 grams per milliliter. Now let's ask ourselves a question. Is this 3.12 grams per 44 milliliters? 3.12 grams per 112 milliliters? No, of course not. It's 3.12 grams per 1 milliliter. Okay, and I'm just going to leave that one kind of small because we wouldn't write it like that. But I want us to understand that there's a 1 there. Okay, so what I can do then is I can go from moles to grams, and then grams to milliliters, and then milliliters to liters. Okay, so I now can build my T-chart. And so I'm starting off with 400 grams of calcium iodide. And then I go from grams of calcium iodide to moles of calcium iodide. And then I go from moles of calcium iodide to moles of bromine. And from moles of bromine to grams of bromine. And from grams of bromine to milliliters of bromine. And from milliliters of bromine to liters of bromine. Wow, this is a long one. Bring everything down. Grams of CaI2, moles of CaI2, moles of Br2, grams of Br2, and milliliters of Br2. Now, most of these are things that you've seen before. I know that I put one with calcium iodide and then do the molar mass, 40.08 plus 126.9 plus 126.9. So my molar mass is 293.88. Okay, moles of bromine compared to moles of calcium iodide, since it was already balanced, that's 1 and 1. Moles of bromine to grams of bromine, I can do that. That's 1 mole of bromine, and I believe the molar mass of bromine is 159.8. And now this is our new one, okay? Grams of bromine to milliliters of bromine. This is where the density comes into play, okay? Which one of these does 3.12 go with, okay? 3.12 goes with grams. And what number goes with milliliters? Well, we said that it's 3.12 grams per 1 milliliter. So 1 goes with milliliters. Now I can go from milliliters to liters, going way back to unit 2, putting a 1 in front of the prefix and the scientific notation for milli, which is 1 times 10 to the negative 3, in front of liters. So now all I got to do is solve 400 times 159.8 times 1 second E negative 3, enter, divided by, open parentheses, 293.88 times 3.12, close parentheses, enter, and I get that it takes 0.069, let's see here, where can I write this? 0.06971 for sig figs liters of bromine to react with that amount of calcium iodide. Okay, that's it, my friends. That's how it's done. And we'll practice more in class.